Alrighty, well, it's 1 o'clock. So good afternoon, everyone, and welcome to the first installment in NEIWPCC's National State Revolving Fund Training Webinar Series. Today's webinar will focus on climate resiliency and adaptation for water infrastructure. My name is James Plummer, and with us from NEIWPCC today, we have Christina Stringer, who will introduce you all to NEIWPCC in a few moments, and Nick Bissonnette, who will be monitoring your questions and leading the Q&A throughout. So without further ado, I'll pass it off to Christina Stringer to introduce you all to NEIWPCC.
Thanks, James. My name is Christina Stringer. I'm a program manager with NEIWPCC. And Nick, if you don't mind moving it to the next slide for me. Since we have strong relationships with our states here in the Northeast, but we thought some of you in other parts of the country might not be so familiar with us, and that it might be worth a few minutes just to tell you a little bit about who we are and what we do. So NEIWPCC is a congressionally authorized interstate organization. We've been in existence since 1947. As you might imagine, the roles and activities that we participate in have evolved quite a bit over the past 73 years. Today, we have about 105 employees working across our region on a wide variety of water-related projects, ranging from monitoring initiatives, source water protection, infrastructure improvements, and staffing estuarine research reserves. All of that wide variety of project activity all goes to serve our mission, which is to advance clean water in the Northeast through collaboration with and in service to our member states, which is all of New England and New York. While doing that, we're really focused on our core values of leadership, collaboration, education, service, and science. All of the work that we do falls into these 5 key areas of impact, namely connections and building relationships amongst the region and across the nation, working on activities, research, monitoring that all serve to protect our water resources, providing training opportunities to develop our workforce for the coming years, providing educational opportunities, and really working towards engaging our stakeholders and member states. So while NEIWPCC does primarily work in the Northeast, we have had a little bit of experience working at the national scale. In 2016 and 2018, we hosted national non-point source conferences in Boston and then in Colorado Springs, which is the picture in the upper left on this slide. We've also run our National Tanks Conference for the past 15 years, hosting over about 10 meetings over the course of that time. And finally, we have published Lustline, which is a biannual newsletter, getting out information about linking underground storage tanks since 1985. So now we're excited to add the SRF educational work to our portfolio and to get to collaborate with a whole new group of professionals. Right now, our current agreement is to provide training and workshop opportunities through 2023. So today is just the start of that process. We look forward to a lot of learning and capacity building over the next few years and to working with all of you. Please don't hesitate to reach out to me or James over the course of the next few years when there's things that you'd like us to see addressing or doing differently. And with that, I hope you enjoy the great lineup of fantastic speakers we have today, and I'm going to hand it back over to James so we can dive right in.
Awesome, thank you, Christina. So as Christina mentioned, we'll just kick things off right now. I'll introduce our speakers and then we'll get going. So Sharon Nall has been working with New Hampshire wastewater treatment plants for over 20 years. Sharon's the manager of the Planning, Protection, and Assistance section with the New Hampshire Department of Environmental Services, Wastewater Engineering Bureau. In this position, Sharon is managing the New Hampshire DES effort to help wastewater treatment plants become more sustainable through improved energy efficiency, asset management program development, and flood resiliency awareness. Following Sharon's presentation, we'll hear from Brandy Piers. Brandy is a licensed professional engineer in Maine and New Brunswick, Canada, with over 15 years of experience in construction. She is currently the senior environmental engineer at the Maine Department of Environmental Protection, directing the Small Community Grant Program which provides grant assistance in the replacement of failing septic systems, overboard discharge removal program that aids in the removal of small package wastewater treatment systems and installs subsurface water systems, resulting in water quality improvements and in some cases the opening of closed clam flats. The Clean Water State Revolving Fund, assisting wastewater communities with low interest loans and principal forgiveness funding for infrastructure improvements, stormwater upgrades, landfill closures, etc., as well as the State Municipal Contraction Grant Program to support the aging infrastructure needs. Jim Lord has been with Dirigo Engineering since 2002. He is senior project engineer and a project manager who works extensively with small rural communities to help them solve problems, upgrade infrastructure, obtain funding, and plan for the future in a fiscally responsible and sustainable way. Bill Brazel has helped manage New York State's highly successful Clean Water SRF since 2003. He's currently the Deputy Director of the Division of Engineering and Program Management at the New York State Environmental Facilities Corporation, a title he's held since 2018. He is involved in many aspects of managing New York's SRF program, including programmatic changes, reporting, and tracking of the program's progress. So that being said, we've got a great lineup for today, and following the webinar, you'll be asked to fill out a brief survey. So please take the time to respond to let us at NEIWPCC know how your experience was. An electronic certificate of attendance will be emailed to the address used to register. And please note that today's presentation has not been evaluated to meet any continuing education requirements. So I'll pass it off to Nick to handle the webinar technology situation.
Whenever you are ready, should be good to go.
Okay, I believe I'm good to go.
Yes.
So thank you everyone for joining us today. And I am going to talk about New Hampshire's SRF journey towards climate change mitigation and adaptation for water infrastructure. Most of my presentation today is going to focus on mitigation, since the other speakers are going to focus on adaptation. When we started this program, we started looking around for how are we going to address climate change and what do we need to work with? And we found that opportunities abound. In the photo in the upper left corner is actually a sinkhole from a failed storm drain in the middle of Interstate 93 in Concord. You can tell it's a relatively large sinkhole from the size of the people next to it. We also looked at our wastewater treatment plants. Typically, they are built in low-lying areas near rivers, like this one in Portsmouth. It's under construction, brand new plant. We want everything to flow by gravity to the plant and then flow out of the plant by gravity to the river. So hence why they're located in low-lying areas, and such they're flood prone. We also looked at our drinking water infrastructure. These two facilities, it's the one facility, it's the same structure before and after a flood in North Conway. The riverbank is no longer there, it rerouted itself. They've now had to move the well. So everywhere we looked, there were opportunities. Some may disagree that those are opportunities, but we saw it as opportunities. Both drinking water and clean water SRF programs, we work together collaboratively to come up with the asset management umbrella of how we want to address climate change mitigation, climate change adaptation. And through this asset management umbrella, we're having communities inventory their assets, figure out their level of service, condition assessment, risk assessment. Communication is a key piece of all of this. Prioritization of their assets is important, as well as also financial planning and life cycle cost analysis. But to really address climate change, we're taking that asset management umbrella and adding more tools to it. And they all build to make it a more effective utility management system. We're supporting planning efforts, energy efficiency, as I mentioned, Flood resiliency, power resiliency, vulnerability assessments, those all go into figuring out where do we need to focus efforts. Even a mindset shift, going from mindset of waste or wastewater to resource recovery. Those all are important pieces of this puzzle. For the rest of today, I'm going to focus on just the energy efficiency tool, or the piece that adds to that asset management umbrella, and what we're doing with that through our Clean Water SRF program as well as Drinking Water SRF. Again, opportunities abound. Energy consumption by public drinking water systems and wastewater combined can represent 30 to 40% of a municipality's energy bill. And you may think that sounds pretty high. Well, we did too, but we looked at it, and one of the communities in New Hampshire was willing to share all of their energy use with us for their facilities. And sure enough, if you add up the drinking water, wastewater pumping, and wastewater treatment, or their water reclamation facility, the bottom part of this pie chart, the total is 43% of the municipal energy use goes to drinking water and wastewater. And you might say, well, 26%, that sounds like a lot for treating wastewater. So we looked at how do they rank relative to other communities. Well, they're one of our most efficient activated sludge treatment plants. So just imagine what percentage that energy use would be for the municipality if this was a less efficient system. Kind of as we were getting started in our energy efficiency program, one of the early things we did, we had the opportunity to update our design standards. And we said, well, we want to try to help these plants come online from upgrades and new facilities more efficient than they are now. Because in the past, everything was built for peak flows, peak demand 20 years in the future, which makes it difficult to operate, and certainly difficult to operate efficiently at day one. So we really encouraged, instead of 2 really big blowers, put in 3 to 5 smaller blowers. Have some flexibility in your operation. You have to meet current peak demand and turn down requirements, which help you meet the requirement to avoid over aerating at the current daily minimum flows. So those were all pieces. We did the same thing for pump systems. And we did encourage, we give them the option of either putting in multiple smaller blowers, or at least leaving room so that as their flow and demands increase over time, they can add a blower or add a pump if they need extra capacity. So we had that in place, and then thanks to EPA giving us a heads up that the Department of Energy had a grant opportunity available, we jumped on board with that, applied for that grant, which, thanks to our partnership that was formed as part of this grant application with New Hampshire Saves, and New Hampshire Saves is a consortium of the energy efficiency divisions for our 4 largest energy utilities, with electric and natural gas. So they became our partners in this grant, providing the 20% match that we needed. And through that grant, we were able to contract directly with our star auditor. This is a picture of him as a younger person. And through that grant, we've been able to benefit directly through relationships and partnerships, both our treatment plants, but then our drinking water SRF program, even though they weren't part of the grant, they liked what we were doing, so they joined in to benefit the drinking water facilities as well. So New Hampshire Saves has helped with those relationships. We've helped them with the relationships, and it's benefiting both our treatment plant, both our water and wastewater. Our grant program, and kind of what we are doing to continue this work as well now that the grant is over, we started with benchmarking. That graph I showed with Hanover compared to other plants, that was part of that benchmarking effort. We benchmarked energy use for a variety of different plants where we can compare different types or similar plants to each other, as well as the same plant to itself over time. We then went on the road with a series of workshops talking about the benchmarking, why that's important, what story it can tell, also describing why energy audits are important and why implementation of the energy audit findings is even more important. And then we wrapped that up for the grant with another round of education, reaching out with having operators that had gone through the program and implemented projects, having them talk to their peers about the benefits and success stories. And we are continuing that cycle, even though the grant is finished. So we had really good feedback from municipalities and a lot of continued interest, even though the grant had finished up. So our Clean Water SRF fund, or staff, said, well, we can provide low interest loans with principal forgiveness for these energy audits. We have some guidance documents. As long as they meet that guidance, they can contract with the STAR auditor that specializes in drinking water, wastewater energy audits, and we'll forgive that loan when the project is finished. But as you know, if you're working in the SRF program, the paperwork for small loans is no different than the paperwork for a large loan, both on the staff end as well as on the municipality end. So we had a few takers for this, but not as many as we would have liked. So the next step was forget the loans. And this is the part that everyone loves because there actually is a free lunch. Through the creative thinking of our Clean Water SRF program and partnering with New Hampshire Saves again, as well as with Drinking Water SRF, we were able to use administrative funds and set aside funds to contract directly with the auditor, and then with oversight from DES, Drinking Water and Wastewater staff, for the selection of which facilities we wanted to audit. We are really putting level of interest on a high on the scale, as well as embracing asset management. Those are things that help them score to receive an audit, an energy audit. So when I get to call and tell a facility that they can have an audit and all they need to do is just email me and say they want it, they absolutely love that. So far, we have, through this program, starting with the grant, we've committed over $800,000 just to doing energy audits. And these are comprehensive process level audits that range in cost from $4,000 to $30,000. Our plants are fairly small on a national scale. And you may think, oh, that's a lot of money to spend on audits. And it is. However, I like to show this slide because it really drives home why every facility needs to have its own energy audit. This is Canaan, Lisbon, and Troy. They are three very similar, very small, very simple lagoon systems. Had they not each had their own audit, we would have said, well, you probably need to optimize your aeration system and we'd be done with it. However, because of the audit, we found that Canaan had an influent pumping issue, Lisbon had an aeration issue, and Troy had an electric heat issue. So three simple plants, three totally different energy efficiency solutions. It really drives home why everyone needs an audit. Now, so far, our audit program has shown the potential savings of 30% for wastewater systems on average, ranging, I believe, from 11 to 58% potential savings. And drinking water has shown 23% average savings. But with audits, it's a report. There's no savings unless the findings are implemented. So looking at implementation, those audit reports out of 41 audits completed so far, it's over $6.5 million in implementation costs. However, the projected annual avoided cost, or the savings, is almost 1.8 million, giving an estimated payback of just 3.6 years before incentives. So that's a lot of interest. Drinking water implementation, we've completed 16 audits so far. got $524,000 of implementation costs with over $200,000 in savings for just a 2.6-year payback before incentives. So getting into the incentives, and I'm going to show a little bit of a case study showing how these additive incentives work. But New Hampshire Saves, Eversource in the case study that I'm going to give, that's our largest utility. They have access to core electric funds, which everyone in the state pays into when they pay their electric bill, as well as Regional Greenhouse Gas Initiative municipal funding, or RGGI funds. Those we're allowing to be combined with the Clean Water SRF loan forgiveness that we have for the wastewater projects, where we've instituted 50% forgiveness up to $200,000 of the principal can be forgiven. So that case study, this is the Winnipesaukee River Basin Program for Franklin, and it's located in Franklin, New Hampshire. This facility is actually owned by the state of New Hampshire, Department of Environmental Services, and it's a regional system that serves 10 communities in the Lakes region in central New Hampshire. It's a prime tourist area, so it's a really important facility. Last year, we selected this facility as the most efficient treatment plant in New Hampshire based on a kilowatt hour per million gallons treated metric. We also have another facility in the state that we selected on a kilowatt hour per pound BOD treated or removed. So to give you an idea of where they were, the Winnipesaukee River Basin is a really good example of EPA's Plan, Do, Check, Act cycle. They've just completed their third energy audit, and they complete an audit, then they implement projects. They complete another audit, they implement projects. So now we're on the third round of that. And right now, they're using 853 kilowatt hours per million gallons treated, which is pretty amazingly efficient compared to a nationwide basis. I'll get that in a minute. After they implement the projects identified in their third audit, that will drop down to about 760 kilowatt hours per million gallons treated. Now, compared to benchmarks I could find from other states, for similar size facilities, type of facility, that benchmark typically ranges 1,200 to 1,750 kilowatt hours per million gallons. So after this next upgrade, there'll be about half of that, which is pretty impressive. So the project, it includes addition of a right size blower and controls. So they're going to improve their process by not over aerating any longer. They're replacing 2 return activated sludge pumps, and they're doing a lighting upgrade. So the estimated project cost is $400,000. New Hampshire Saves, Eversource, as I mentioned in this case, has committed $100,000 to this project. The Clean Water SRF has committed $200,000 in loan forgiveness. So the final cost to the loan recipient is just $100,000 for this work. The impact on the incentives of the simple payback, well, prior to incentives, payback was 11.2 years. It's little on the long side, considering the equipment will probably last. It's got a 20-year life expectancy at least. The operators tend to keep things running longer than that. So it would still be cost effective. But after the incentives from New Hampshire Saves and SRF, the simple payback is just 2.8 years. So now it's certainly a doable project. Then you look at the non-economic benefits that really add to that cost effectiveness. As I mentioned, improved process control. They're going to be able to no longer over aerate. They will be able to monitor and control their dissolved oxygen with the control system that's being put in. So they're really optimizing how much air they're putting in the system, how much energy they're using. They're lowering their equipment repair costs. They've got new equipment, so now they can focus on where that repair budget needs to go. They're also improving their reliability, both through redundancy, they're adding a blower. They're lowering their energy use, so now if they're without power for an extended period due to a storm, they have more equipment that they can run on their generator. So all of that plus new equipment typically is more reliable. They're also improving their working conditions. I don't know how many of you have been into a dark, dungy pump room that no one really wants to be in because they can't really see, the lighting's not very good. But when you upgrade the lighting, you can now see what you're doing to work. You can also see that it's a mess, clean it up, and now it's not a bad workplace. So everyone benefits on that. To tie it back into climate change mitigation, the impact on the greenhouse gas emissions from reducing power energy usage down over 307,000 kilowatt hours a year will result in power plant emission reductions of over 400,000 pounds of CO2, over 1,000 pounds of sulfur oxides, and over 300 pounds of nitrous oxides. So that has a long-lasting effect. Now, Winnipesaukee River Basin is a really good example of how to implement this type of process where they've figured out their energy costs. They hired their star energy auditor. They implemented energy upgrades, energy efficiency upgrades, and they saw savings. And then they took some of those savings and they've gone through that process 3 times now. So now they're really looking at what can we do for renewable energy? That's probably the next phase for them. And that, if they can implement renewable energy, whether it's solar or an upgraded anaerobic digester system, something that's cost effective, then they can make those savings permanent and make the greenhouse gas emissions permanent. So kind of tying this all back into the asset management umbrella and the climate change piece is our operators, drinking water and wastewater, they are amazing MacGyvers, we like to call them. They can keep some equipment running way past its expected life. But really, is that really the best answer for user rates, for energy efficiency, for climate change, for resilience? Those are the questions that need to be answered, and the data from energy efficiency and from asset management can help answer those questions. With that, do you have any questions?
Great, thank you, Sharon. Appreciate it. At this time, invite our audience to send in text questions, and please just keep in mind to address all questions to a speaker. So on slide 19, you had turned down requirements, and we just wanted to get a little bit of a clarification around what those are.
The turn down requirements, a lot of the turbo blowers, they cannot turn, they have a very narrow window of where they can turn down, and some of the manufacturers will tell you that they can turn down, basically turn down by slow down and lower the airflow delivered. Some of them can go down, but they can't go back up, which means they really can't go down that low. So they have a very narrow window of efficient operation.
Okay, great. And that is all the questions that we had. Oh, the one just popped in. Are the costs construction phase, or are they also inclusive of design fees?
What we have found is the costs that the energy auditor is citing are a little bit on the low side, and design costs are adding a little bit to those costs, but not to a point making it no longer cost effective. So we're working with him to be more realistic in what needs to go through our design review process and needs to be designed by a professional engineer versus what can be done by staff? That's a good question.
Okay, great. And with that, we will keep the presentations moving. So next we will have Brandy Piers, and I will go ahead and make you the presenter at this point, Brandy.
All right, now, my name is Brandy Piers, like we had talked about before, and today I am here to talk to you about the State of Maine's Clean Water SRF and Climate Adaptation Plan. So what is Maine doing? We're looking at knowing your risk, climate adaptation planning, and Maine's current status. So I'm not sure how many out there really know what your risk is, but this could be you in a few years. You could have an aeration system underwater, or this used to be a coastline. But knowing your risk doesn't mean you only know the risk on the coast. From here, you can see that also inland, we still have to deal with climate change. There still is flooding. So it's not just a problem of the coast. As well, here is another picture of rain and snowpack and rising temperatures in northern Maine. So next I wanted to talk to you about a survey we sent out. We sent this survey out to some of our wastewater communities, and the state of Maine has a little over 200 publicly owned wastewater treatment facilities. This survey sample was 52 wastewater utilities were sent this survey, and some of the questions that we asked after having 29 responses, meaning 56% response rate. Some of the questions that we asked were, has your facility operation ever been impacted by extreme weather events? Well, as you can imagine, everyone that answered these surveys, 91% said they've seen extreme weather events affect their community. Only 3 communities responded no. So what does that mean to us as a regulator? As a regulator, we have to look at this. It means we need to stop and assess our wastewater treatment plant. And what can we do to help? Another interesting question that we had was, have you made any plans to protect assets from changes in climate? 47% said yes, and only 53% said no. Interesting facts, don't you think? Now, let's look at another important question. Is climate adaptation part of your annual budget? Wow, 100% responded no. No one is making climate change or climate adaptation practices part of their annual budget. The last question that we looked at was, would you ever consider adding climate adaptation to your annual budget? And 61% said yes. Which leads us to the next slide, which is climate adaptation planning. Climate adaptation planning. Please keep in mind that each state is going to have their own climate challenges and or climate stressors. Here in the state of Maine, for wastewater communities, most of the common challenges and or stressors are listed here as heavy precipitation and floods, severe storms, sea level rise, storm surge with sea level rise, ocean acidification, drought, ice storms, heavy snowfall, stronger winds, and temperature change.
So how can we help is what we like to say in the state of Maine. How can we help you to succeed? So we decided to look at different situations in different communities, and we did some research to find out exactly how much money we could provide to a community for a climate adaptation plan completed by an engineering firm. And we all know these can vary in cost dramatically, but at the end of the day, we ended up coming down and deciding that up to $20,000 per borrower for the state of Maine would create a really great climate adaptation plan. It's a good start. So we decided to try to offer financing in two different ways. The first way that we decided to offer financing was for climate adaptation plans, or as we like to call it, a CAP, with a capital project, meaning it would have all of the clean water SRF requirements in it, including American Iron and Steel and Davis-Bacon. So if there was any leftover money upon completion of the capital project and the CAP plan, funds could be used towards items identified in the plan to help things progress. And the other option we had to finance these plans is as a standalone plan, which means exactly that. It is only a plan. And any funds left over from the $20,000 would be returned to the program and cannot be used towards recommended projects. So now that we've talked about having a climate adaptation plan, let's get into some components of what we're looking for in a climate adaptation plan. First and foremost, you need to have a great team assembled. A plan is only a plan that's going to collect dust if you don't have a good team assembled. And in order to do this for a climate adaptation plan, we're asking for the town manager, the city manager, superintendent, selectmen, the fire chief, the police chief, any first responders, potential FEMA representatives or MEMA, as we have in the state of Maine, to be involved in this team effort. Because if something happens and nobody knows you already have a plan, it's just collecting dust and it's a waste of money. So this plan is meant to be operational on instant notice. The next item is, of course, identifying your hazard. What is your hazard? Do you know what your hazard is? How are you affected? Is it sea level rise? Is it floods? Is it precipitation? What are your hazards? How do they affect your system? The third component is identifying your vulnerable asset and determining the consequence of the hazard. So what does that mean? If you've decided that flooding is your hazard, what happens when that pump station down the road is flooded or a road is flooded to get to that pump station? Do you know how you can get to that pump station? Do you know what your protocol is to alleviate that pump station? This is where determining what the consequences of not having that pump station is very helpful. The fourth item is evaluate adaptation practices. Provide, how would you help the situation? Now that you've identified what your asset is that's vulnerable, what can you do to prevent or adapt to a potential hazard? And I know I'm just using flooding for the example, but just, you know, it's one that's in the forefront of everybody's mind. So how can you adapt to the practice? Does that mean that your pump station has to be raised up? Does it mean that the electrical system, the electrical panel on the outside of the pump station should be raised up? What does this mean to your system? You need to figure out what the resiliency and what the adaptation practice is going to be. The fifth item is development, implementation, plan of recommended adaptation practices. How can you reduce the potential for your hazard to affect your system? How can you reduce any damage to equipment? What do we need to do to stop any interruption of service? Or maybe interruption of service is okay. If this is a pump station at the end of a dead-end road and there's only 2 houses on it, maybe it's okay to shut that pump station down during a flood event. But it's not okay to shut that pump station down during a flood event if it's the main pump station. So these are the things that you have to decide for yourself. The sixth item that we want to see in these climate adaptation plans is how are you going to integrate your CAP into utilities asset management plan and or your capital improvement plan. How are you going to find the money to do this work? Do you know where to go to get money? How are you going to fix these items if this flood happens and FEMA's not ready to give you any funds and you're not prepared for it and it's going to be a while? Who do you ask for money? Maybe it is going to the Clean Water SRF program to get a loan in lieu of going to FEMA right out of the gate because you know it's going to be a long time before you see the funds. Maybe you have to start looking at this plan and figuring that you need to start setting aside money and having the community buy in to the fact that you need to put this element in your capital improvement plan. These things are important, and we all need to know that we have to move forward. And in order to move forward, we need to have all of the information at hand. We need to try to be proactive and not reactive. This is one more way we can help. This slide is on Maine's current status on climate adaptation plans. We started doing climate adaptation plans in 2015, which we had said that you could only do a climate adaptation plan originally with the capital project. However, in 2017, communities reached out to us and asked if they could do a standalone climate adaptation plan. And because we are here to help, we agreed to that. And we said it's okay. And as of right now, we have 28 applications totaling $560,000 in principal forgiveness, aka grant funds, to our wastewater communities, which are currently in various stages of the plan. However, in 2020, we had so much interest in the climate adaptation plans that this is the first year that we've had to turn down communities that want to do a climate adaptation plan to move forward. And I'd just like to point out the map of Maine, and all the stars that are shown on this map are some of the climate adaptation plans that are currently underway. And as you can see, they're not all on the coast. A lot of them are, but they're not all on the coast, which is a good representative of how we all need to think outside the box and how we all need to plan for climate change in one form or another. Thank you so much, everyone. And if you have any questions, I'd be glad to answer them.
Great, thank you, Brandy. We appreciate that. At this time, again, I'd like to encourage any of our audience members to address any questions to Brandy at this point. One question is using the use of leftover funds and purchasing other items in the cap. Do you have any examples of that?
Sure. So some of the examples of items that can be purchased are things like electrical panels, new electrical panels, because they need to be moved up, or you know, sometimes we see the purchase of manhole covers that can be locked down for so that if flooding happens, that the flood doesn't inundate the sewer system.
Okay, thank you. One question here. Did phase one of the 6 phases that you had listed include practice scenarios of for the personnel identified?
Sure. Well, when the personnel or when the team was assembled, they would talk about what was important as a first responder for each one of those items, and they would discuss different scenarios that would happen and what would be the most important scenario to move forward on.
So I think with that, we will go ahead and continue. So we say thank you, Brandy, for answering those questions and the presentation. And at this point, we would like to transfer it over to Jim Lord. So we'll go ahead and make you the presenter. And you should be good to go whenever you're able.
I am good to go.
Great.
So this is Jim Lord. I do work with Dirigo Engineering. We specialize in water and wastewater systems for rural communities here in Maine. We've been asked, we're providing a case study on a climate adaptation plan we worked with the DEP on in the town of Brownville. We completed in 2017, and what I'd like to do here today is work through that. We've been working with Brownville since 2008, so this was a good opportunity to get to know a different aspect of some of the impacts they've seen over the years. So what I'd like to do here is introduce Brownville and their wastewater system, which we'll focus on, describe their experience with extreme wet weather, which they've been hit a number of times over the last 30 years, describe how the team was assembled, which, as Brandy alluded to, is extremely important, and I'll stress why in some of the things that we got into. Describe some of the work we did, describe the ultimate findings and recommendations, and really hit on some of the key aspects of the plan and what I think made it a success that they're still using today. So also Brownville is, located in the center of Maine. It is not in fear of sea level rise. It's got a small population of about 1,250 people. It's 50 miles from Penobscot Bay. It's at an elevation of 350 feet above sea level. Annual precipitation is just under 47 inches with annual snowfall of around 92 inches. The Pleasant River runs right down through town. The town is basically aligned along it. It has 2 major villages, totally independent of each other, if you will, in the terms of utilities. The water systems, they have 2 water systems and 2 wastewater systems that serve these communities. Both are departments of the town. An important aspect of that is the public works for the town of Brownville also serves to support the public water and public wastewater systems. So let's talk about the wastewater system in each of these villages. Brownville Junction has a conventional gravity collection system, mostly PVC piping with precast manholes that was built in the late 80s primarily. They have 1 main pump station, which is a dry pit non-clog style pump station, which collects all wastewater and pumps it to the treatment plant. They have 4 smaller submersible stations, all grinder stations, duplex stations, with a centralized wastewater treatment facility. That treatment facility is a large engineered subsurface septic system. The one main pump station does have a committed generator on site. The 4 smaller stations does not. They have receptacles for a mobile generator. In Brownville Village, there are 11 cluster subsurface systems, each serving 2, 3, 4, or 5 houses that all flow into a septic tank with an effluent pump station. That pump station pumps it up to the disposal field or fields. Some of them are larger, some are smaller. Of these 11 systems, none of these systems have permanent generators. They all have receptacles. As you can see, so let's focus on Brownville Junction for a minute. You can see the map here of the system as it's laid out with the Pleasant River going right down through the middle of it. On the west side of the river is the primary collection system area and 4 of the 5 pump stations. On the east side of the river is, up in the top right corner, the wastewater treatment plant and a small collection system area with 1 pump station. The importance of this, as we'll get into a little bit as we go along, is access to all of these facilities and the fact that you have a major river segment and many tributaries running in this area. So here are a couple of the pump stations. The main pump station on the left, as you can see, there are stairs up to it. The wet well is elevated up. The generator is in the building. The pumps are in the basement, and they have prepared. It is designed to be above the base flood elevation. Typical submersible station on the right. Again, there's a platform. It is elevated to be above the base flood elevation. So they were prepared with the facilities that they built back in the late 80s to be above the base flood elevation. It was the one thing that everybody was looking back then was floods. This is Brownville Village. It's about 6 miles south of Brownville Junction. It's a little bit harder to see, but all of these 11 cluster systems basically along the river on both sides of the river. There is a bridge that crosses right in the center of town. And again, all of these systems are subsurface systems. Here is what you'll see is the effluent pump stations after the septic tanks. The control panels are elevated a little bit. The wet wells are down on the ground. Not one of these stations when we came in had flood tight hatches. So we went in and we assessed the climate related threats for Brownville using EPA software. University of Maine had done a study. There's a fair amount of information out there that was really helpful in figuring out what the actual threats for Brownville might be. Floods being one of them, clearly. Increased annual precipitation. These are subsurface systems. If groundwater rises, it could affect treatment ability. Increased storm intensity. I&I, overloading systems, increasing pumping times, all of those things. Extreme wind. When you have 11 sites in rural Maine of varying topography and trees everywhere, wind knocks down trees a lot, it knocks down power a lot. Winter storms, snow and ice. So these were the big ones for Brownville. And so we started with floods. And so we pulled up the flood map. And as you can see, the stars indicate all of the pump station locations, and they are all over the place. And though very few of these facilities are actually in the floodplain, what you'll see is it's going to be tough to get to each one of these without crossing a floodplain to get to it. So access to each of these facilities became incredibly important. The other issue is Brownville Village, which on this map, which is on the right end, when this map was originally developed, there was a dam just upstream of Brownville Village that's since been removed. So we didn't really know the current actual flood elevation, base flood elevation for Brownville Village. As Brandy alluded to earlier, the funding, the $20,000, Brownville did get a $20,000 grant. It went along with the facilities upgrade capital improvements program project. And a share of that was used to hire a hydrologist to actually define the base flood elevation for Brownville Village, so we knew what it actually was in current information. So then we went back through the history of what has Brownville seen in recent times for extreme weather events. Well, in 1987, there was a statewide flood of monumental proportions. Some areas were 100-year floods, some more, some less. Brownville actually only rated to about a 45-year storm that year. In 1998, the ice storm hit, which, as most people remember, was 5, 6, 7 days, sometimes longer, with no power, extreme ice, trees down everywhere. As I alluded to earlier, the public works crew teams as the water and wastewater operators for these systems. So not only did they have to keep roads sanded and cleared and trees cut, they had to get to all these facilities with their mobile generators. 2008, a 50-year flood when Brownville received 6 inches of rain in one day. 2012, they had a severe thunderstorm that stalled over Brownville and dumped 6 to 8 inches of rain in a 6-hour period. The topography in Brownville, it is a valley. The river runs right down through a valley. So all the rain that hits in the area around it swarms right down to the 2 villages into the river. And then in 2020, this spring, Brownville received around 18 inches of heavy, wet snow that knocked trees down, power down. It was incredibly devastating to them. The public works crew, the wastewater crew, all teamed up. It took them about 4 days of working around the clock to clear trees, clear roads, to reestablish access to all of these facilities while trying to keep pump stations going, while trying to keep everything active. Here's a picture of the 2008 50-year storm, and you're looking at the Davis Street pump station, which, yep, it's high and dry, it's above the flood, but how do you get to it? How do you bring a mobile generator to that facility? This is one of the situations where if the controls were actually moved, just a short distance, then you could access the controls and connect the generator to it. So access was really a big part of what we found was an issue here in Brownville. You can see the bridge in the background. You can get across the bridge, but you're not going to go anywhere then. This is another picture of the 2008 flood, 50-year flood. Now this picture became incredibly important because though there was no wastewater facilities there, this was an area we didn't know what the flood elevation was. So we reached out to local historians, selectmen, received pictures from them, and we were able to survey this area and hit these points where at the peak floods really helped us to establish the model to define what the actual flood elevation is. 2012, here's a few pictures. Roads were washed out, culverts were washed out, sewer mains actually floated in certain areas because water would just erode the ditches, and sewer and water was put in the ditches sometimes, mostly in the roadway. There was impassable for a number of days. Again, Brownville Junction is a huge railroad yard. It is very, very active with railroads. They lost a lot of rail transportation through there. Roads were, like I said, extremely damaged. Some of these may be in rural areas, but they were also bypass routes to get from one station to another in the case of a flood event. Winter storms and ice storms, as you can see on the right, that was this spring's snow event, and this was extremely common across central and northern Maine, and certainly in Brownville. A smaller ice storm on the left, that was not the 1998 ice storm, but these happen to one degree or another almost every year in Brownville. So the climate adaptation plan goals was to assess how climate change might impact the wastewater system and the potential impacts to the environment. If you have issues in your wastewater system, floods or whatnot, and systems aren't pumping, what potential damages happen to the environment? This is equally important as the damages to the systems. Develop and prioritize and then implement strategies for dealing with climate change. Education for the operators, community officials, regional agencies, and then the general public. If everybody understands what's going on, it's certainly a lot easier to deal with and a little more efficient to get from point A to point B. So Brownville's team, one of the things I'd like to stress about this, we did brought in the select board, 2 of the members with historical knowledge, but not only historical knowledge, they had the authority to act. The town manager, they were at all meetings. We had multiple meetings. Every time we would collect a bunch of data, information, and assess it, we would gather. We would go out to sites. We would look at. The other thing is we collected a great deal of historical photos, like I said, and we used that to show everybody there, the selectmen, the town manager, the public works director, wastewater operators, the Maine DEP, and then the regional emergency management director, who was a lot more local than the state level and had the ability and the resources to react. So bringing everybody into this team and getting everybody to really understand what the real issues were and what the resources were was huge. So some of the critical work tasks that we had to work through for Brownville was determining the actual flood elevation at these various areas. They have 17 sites between pump stations and the treatment plant that were in and around floodplain areas prone to, extreme weather events. Evaluate the risk at each facility, because it's different, even though most of them are general and apply to all, then some specific sites are different. Access to each of these sites, safety at these sites, operator safety, ice storms, potential impacts to facilities and the environment, as I discussed here a minute ago, and then prioritizing the risks, reviewing all of this with towns' local resources, what Public Works had, what neighboring communities had that were on the other side of the river, where your resources were. Developing a list of potential capital projects to mitigate risk, developing a list of potential operation strategies. In Brownville's case, as you'll see, operational strategies were as important as the capital improvements to help reduce impacts, to prepare everybody, and to really handle storms more effectively. To educate the people that needed to know, as well as the community, and then to implement it. So critical findings and recommendations. So for Brownville, the most likely impacts from most likely threats: power failure, loss of accessibility and reduced site safety, and direct damage. Now, direct damage was actually low on the list, as most of the facilities had been built above the floodplain, were constructed properly, with the exception of flood tight hatches, which is one of the capital improvements we recommend later on. But power failure, I want to say, we still work with Brownville. We've been working with them since 2008. I talk to their wastewater superintendent weekly. They lose power 6, 7, 8 times a year, every year. And when they lose power for days, not hours. Loss of accessibility. Every major storm trying to get to these 17 sites is a huge undertaking with a small staff. And then site safety, long hours, dark, things that you need to consider as an operator. So recommended capital improvements: the purchase of additional mobile generators. They had 1 mobile generator when we started this study. Strategically locating these generators to understand your access and having people available in those areas that know what they're doing, that can react for you. Safety measures such as sand and salt at each facility with a shovel for operators to keep safe, so when they show up in preparation for a storm, they can lay sand and salt down ahead of it. Having spare parts available, flood tight hatches. Performing an I&I study. The more inflow and infiltration, the harder things work. You can inundate pumps, things like that. So trying to eliminate those sources and reducing your flow in your system was a big part of what we came out of this study. And relocating controls on some of the stations so you can access them during extreme events. Some of the O&M efforts we recommended is to assume all forecasted storms are going to exceed their forecasted strength and duration. Don't predict it's not going to be that heavy a rain. Well, if you plan for it, you're better prepared for it. Fuel all generators, keep all generators fueled, working, tested. Cut back trees annually around stations, controls to the best of your ability. Educate customers on potential impacts. Inspect and clean culverts. Plugged culverts can lead to erosion, can lead to failures, can lead to other issues. Ensure safety measures are at the ready at each site. Critical information used during this study to become successful in this was historical pictures. Help accurately define where the flood levels reached at each of these major events. Active involvement of the town really helped to sustain actual knowledge. Operators, selectmen who had been on the board for years and years, trustees, know what they really went through during any major storms. It's really important to talk to the people that lived in these communities, that worked in these systems when major events hit, to understand what they went through and how to help improve upon that. The Maine Department of Transportation was a big help. They have a bridge in Brownville Junction, a bridge in Brownville Village. Their design information, their water information, their historical information was used to help us. Knowledge of nearby wastewater systems and their resources. Talk to your neighbors. What do they have? What do they need? Where do they feel like they're short? Where do they feel like, if you're hit, Brownville was hit, Dover wasn't in 2012. They're, 20 minutes away. And Dover was able to support by bringing up equipment and supplies. So those types of things are important. I think some of the key knowledge that was gained by the town and the team was to know the flood level along, not just at each facility, but along every access route, to really understand the risks and to have the town. If you're driving in a car and you're a passenger, you're not going to remember how you got there as well as if you were the driver. It really is important that the team be fully integrated in all aspects of this work. And not just given the report at the end. It won't mean as much. The potential impacts to facilities and the environment, better understand the town's resources and the resources around them. When a selectman is given a report at the end, rather than actually seeing it, being out there and seeing what the operators go through, that's important. That's important for budgeting. It's important for understanding. And then the plan to prepare and react for storms. Specific to Brownville, 17 sites. Which one's most important? Well, there's multiple factors in that as far as potential risk of failure. What happens if a system fails? And then some systems, like Brandy alluded to on a dead end street, they actually have some systems that they don't, get 100 gallons a day to. Knowing which ones you have to reach first is critical in being efficient at what you do. And then a long-range plan for capital improvements. I certainly would like to stress before I hand this over for questions and answers, the team to me is the biggest piece. If you're going to undertake a capital improvements plan, put a team together first and make sure they understand that they're not just going to be a part of reading the draft copy and commenting. They're going to be at meetings. They're going to be on site. They're going to go out and see what these issues are, what the damages could be, start helping you collect data, historical information. And it really is important to have regional people a part of this, as well as the people that have the authority to influence your budget. That's in essence what I have and what I found throughout this.
Great, thank you so much, Jim. Appreciate that. So again, audience, if you like to ask Jim a question, please take this opportunity to do that in the questions pane. First question that we have, how long did this planning process take? There's a mention of several years and meetings, so just getting an idea of what the time period was.
On this one, it did because it was part of a capital project. And from the design phase, when we reached construction, construction lasted about a year and a half. We started the climate adaptation plan when construction started. By the time we were in construction and had bids, we knew what facilities were going in essentially. So we waited until that point. Sometimes bids come in high and you have to cut certain pieces out of your project and things like that. So we actually had about a year to do this. We needed to go through some certain weather seasons to do the flood study, to get some information. So we took our time to do it. I want to say there was 6 to 7 meetings throughout when things got heated. Like I said, gathering information took a couple of months before we really started on developing the plan, determining the risks and all of that. So I'm going to say about a year from start to finish.
Great. I think in the interest of time, we will keep our presentations moving. So thank you again, Jim, for that. This is the time where we will transfer the presentation to Bill. So let me just do that.
All right, thanks, Nick. Good afternoon, everyone. In New York State, we've had a few initiatives related to resiliency over the years. I'm going to talk about a few of them, two of them. All right, I'm going to start with two items in our engineering report outline. A number of years ago, we developed an engineering report outline along with our sister regulatory agency, the Department of Environmental Conservation. And because of the engineering report outline, we receive engineering reports that are in a nice standard format, easy for us to follow, and it also can be used with other funding agencies. When consultants follow the outline, we get a nice thorough evaluation of existing conditions, and that helps to provide a good foundation to justify any needed improvements. So two of the topics that we've added to the outline in recent years are energy efficiency and flooding considerations. All right, energy efficiency measures. The 2010 and 2011 CWSRF CAP grants included a requirement to provide some additional subsidy. And we in turn then provided principal forgiveness or grants to communities. And in order to promote energy efficiency, we required that an energy evaluation be conducted in order to receive the last 20% of the grant. And we partnered with the New York State Energy Research and Development Authority, or NYSERDA, to complete FlexTech energy evaluation reports for all of those projects. Since 2011, we've not required the energy evaluation reports, but we have continued to promote energy efficiency through our engineering report outline. NYSERDA a few years ago developed a best practices handbook for wastewater treatment plants, and it identified items such as high efficiency motors and fine level diffusers and things that can be implemented at the treatment plant in order to be more energy efficient. So we require that the engineering report evaluate what energy efficient measures can be implemented. And currently, we are not providing any grants for energy efficiency, but we're going to be changing that. Since 2009, we have provided, we've run the Green Innovation Grant Program to provide grants to projects around the state. For many years, we focused the GIGP program on green infrastructure, but we're going to be expanding that to energy efficiency projects such as biogas. All right, flooding considerations. We're also working to fund projects that are protected from the threat of flooding. A couple of photos on the right there of the city of Binghamton, the Binghamton-Johnson City Wastewater Treatment Plant. They had a major flood in 2006 and 2011. You can see the blue tops of the digesters in both photos, one surrounded by floodwaters and the other on a drier day. Okay, so for the flooding evaluation, the consultant needs to review existing data such as the flood insurance rate maps, and check for the presence of a floodplain. They need to discuss any controlling elevations such as the 100-year flood or the flood of record. Consider the impacts of floodwater elevations and recommend protection measures such as raising equipment to a higher elevation or installing flood doors. Flood elevation standards. Historically in New York, we've used 10 state standards, but in recent years we've relied more heavily on TR16 prepared by NEIWPCC. So 10 state standards requires that the treatment plant remain fully operational a 25-year flood with protection against structural, process, and electrical equipment damage, and a 100-year flood. PR16 is more stringent, where critical equipment has to be 3 feet above the 100-year flood elevation, and non-critical equipment 2 feet above the 100-year flood elevation. PR16 also requires that existing facilities be improved to the maximum extent possible to meet this flood protection criteria. So evaluations might show that there's challenges to implementing the increased levels of protection. And also we asked that the engineer, the consultant, they look at the potential or possible vulnerability of the facilities and the differential cost to raise them up versus the replacement cost of new equipment. All right. I'm going to talk about the storm mitigation loan program. Kind of ironic as a remnants of a hurricane are raining down on my house. On October 29th, 2012, Hurricane Sandy came ashore in New York and New Jersey, did a substantial amount of flooding, flood-related damage. Congress passed the Disaster Relief Appropriations Act of 2013, which provided $600 million to New York and New Jersey for resiliency projects. Split between the states, New York received $340 million, and with a 20% match, the total amount of financial assistance was $407.6 million. The $407.6 million was split between the Clean Water State Revolving Fund at about $340 million and the Drinking Water State Revolving Fund at $68 million. And these projects funded by this program were related or limited to mitigation projects. So either reduce flood risk, damage, and vulnerability, or enhance resilience to rapid hydrologic change, or because of a natural disaster at treatment works. All right, the slide shows some general information about SMLP. The Storm Mitigation Loan Program could fund all stages of the project, planning, design, and construction. We provided a 25% grant and 25% interest-free loan for up to 30 years for these projects. And the projects were limited to 14 counties in New York State. New York City, is, for those not familiar, is 5 counties plus another 2 counties on Long Island, and then 7 counties north of New York City. And so the program was limited to projects in those counties. All right, more about the SMLP. Funds had to be committed to projects that were in construction, ready to proceed with construction, or otherwise positioned to disperse funds quickly. Applicants were required to list their project on our intended use plan, so we requested that applicants list projects. We set a deadline of April 1st, 2014 to submit a listing form to us. And then in August of 2014, we issued an amendment showing the eligible projects and requesting financing applications. Funding was available on a first come, first served basis. Again, trying to move things along quicker for this program. So we implemented this by having multiple application deadlines. The group of projects that were submitted by the first deadline, December 1st, 2014, they were reviewed and awarded as a group. And then the next deadline was June 1st, 2015. So any remaining funds were awarded to the projects that submitted applications by June of 2015. And I believe at that point we had awarded all of the available SMLP funding. All right, some of the financial benefits of the SMLP. we closed the short-term financing with all of the applicants. It's interest-free financing, the 5-year maturity, and we did not charge any issuance fees for that financing. So when construction is complete or nearly complete, we converted the financings to long-term financing. Again, 25% grant and then 75% interest-free financing for up to 30 years. Again, we did not charge any issuance fees on the long-term financing. We do, however, charge an administrative fee. It's an annual fee of 0.25% of the outstanding balance is charged each year on those loans. All right, I'm going to talk about some of the technical requirements of the storm mitigation loan program. First, the applicant had to determine the base flood elevation. They had to use the best available flood hazard data from FEMA. So it could be the flood insurance rate map, an advisory base flood elevation map, publicly released working maps, or even preliminary flood insurance rate maps. And using the base flood elevation information, the engineer for the project had to design facilities to meet those requirements. These requirements were special for the storm mitigation loan program and different from what we see in TR16. So the baseline standard, they had to go with the most stringent of either 100-year flood plus 2 feet, sandy high water mark plus a flood, or the 500-year flood. And then for critical equipment, if it was in an area exposed to sea level rise, we were looking at 100-year flood elevation plus 5 feet, the sandy high water mark plus 4 feet, or the 500-year flood. And then critical equipment in areas not exposed to sea level rise was the 100-year plus 3 feet, or sandy plus 2 feet, or the 500-year flood elevation. I'll note that in nearly all cases, the 100-year plus however many feet is added, that was generally found to be the controlling elevation. All right, and lastly, I'm going to talk about a case study in Nassau County, Barnes Avenue Interceptor Sanitary Sewer Overflow Correction Project. It took place in an area that had a history of SSOs during wet weather. Sewers in this area served the hamlet of Baldwin and village of Hempstead in Nassau County. And the SSOs typically were surcharging manholes. And this area had significant damage, very near the southern shore of Long Island, had significant damage after Hurricane Sandy. So the solution here was the installation of a flow diversion pump station and force main, and then also the upgrade of the Newman's Court pump station in the village of Hempstead. So the basic idea was to divert about 3.75 million gallons a day from one of Nassau County's wastewater treatment plants, the Bay Park Sewer Treatment Plant, to the county's Cedar Creek Treatment Plant in order to mitigate overflow conditions. It basically had too much flow, overwhelming the sewers in one area, causing the surcharging, so they diverted flow to the other treatment plant. And here I have a few photos of the damage that was evident after Sandy. And this slide summarizes the project cost and the timeline. The total cost of this project was about $44.1 million. The county received a FEMA grant of about $5.1 million. And then their SMLP financing from us was about $6.3 million grant and $19.1 million interest-free loan. Now, there were also additional costs on this project, and we provided our regular subsidized SRF leveraged financing of about $13.5 million. So all that gets them to the $44.1 million price tag for this project. And then for the schedule, they closed the short-term financing in September of 2015. started construction the following spring. And when construction was nearly complete, we closed the long-term financing in June of 2019, and construction then completed in November of 2019. And then we have some photos of the completed work, high and dry. Hopefully we'll stay that way. And that's what I've got. Thank you.
Awesome, thanks, Bill. I appreciate it. So now if we can set aside some time for any questions for Bill, that would be great, and please address them. First question is there a general cost estimation for using the protective measures for TR16 versus the 10 state standard?
So you're saying an additional cost to comply with TR16's recommendation versus 10 states?
Correct.
Is that the question? We have not evaluated that question. You know, there's certainly, people do raise the issue of, you know, to what flood elevation do they need to build to? You know, with Hurricane Sandy, with prior to that, with Irene and Lee, we had flood events in upstate New York that probably a few years prior people would not have said possible. So while there is a cost certainly to building facilities higher, we are seeing flood events, and to raise equipment up is in our judgment prudent.
Great, thanks. For the case study in Nassau County and diverting the flow, was that a permanent change, or was there any flexibility to go back?
As I understand it, that's a permanent change. They've just permanently diverted the flow from one treatment plant to the other.
Great. With that, I think that's all the questions we have for Bill at this moment. Definitely was a lot of information, so we appreciate everyone being here and letting us, be a part of it. So we would like to go back and visit any questions that we might have for any of the speakers, any general topics that we would like to discuss at this point. But all right, so I think, here we go, we have one. How are states incorporating climate resiliency into their SRF scoring systems? So that question is not directed towards anyone, but if anyone does have anything to contribute on that, that would be the opportunity.
This is Sharon with New Hampshire. I know that I believe this year we started providing extra scoring points if a project addressed a flood issue or flood resiliency. And we revisit that each year to see where we need to go with those incentives. We also, it scores more points if it's an energy efficiency implementation. And then the asset management also adds points.
Great, thanks.
Hey, Nick, this is Brandy from Maine. And in Maine, we have been looking at affordability, and we have 5 criteria for affordability and how they rank. Plus, we have a whole other environmental system of ranking them. But at this time, we haven't given specific point allocation to increase levels to climate adaptation plans.
Thank you, Brandy, and thank you for submitting that question. So I think that might be all the questions that we have coming in at this moment. So in that case, I think I will just pass it off to James to close us out.
Thank you, Nick. Again, I'd like to thank Sharon, Brandy, Jim, and Bill for taking the time to present to us all today and for sticking around for to answer some questions. Thank you to Nick for leading the Q&A and coordinating this up to this point. Over the next few days, we'll be sure to post the recording of this webinar on the NEIWPCC website, where you can also stay up to date on future SRF webinars and workshops. Just so folks know, the webinar planning committee is looking for topic ideas and speaker volunteers. So if you have any suggestions or would like to volunteer, please feel free to reach out. And we look forward to hosting you for our future webinars and at our in-person workshop currently scheduled for July 2021 in Portsmouth, New Hampshire. Take care.